It begins with the press of the Enter key. Beneath your fingertip, the keycap pushes down on a mechanical or rubber dome switch. At that instant, two metal contacts touch, and a small current flows through copper traces on the keyboard's circuit board, signaling that the key is closed. Inside the keyboard, a tiny microcontroller is constantly scanning a grid of rows and columns to see which keys are pressed. When it notices the Enter switch has closed, it packages the key's scan code, and any modifier flags into a standard USB human interface device report stored in its memory. Every millisecond, that microcontroller converts the report into a stream of bits, using the USB standard rules for encoding and framing, and drives it onto the data lines. The electrical pulses travel down the USB cable, twisted pairs carrying voltage differences, until they reach your computer's USB host controller chip. The host controller, using direct memory access, DMA, places the incoming packet into system RAM and signals the CPU with a hardware interrupt. In a few dozen nanoseconds, the processor pauses its current work, switches into kernel mode, and runs the USB driver's interrupt handler. That code extracts the scan code and hands it to the operating system's input layer. The OS translates the raw scan code, plus any shift or Ctrl keys, into a logical Enter key event and wakes any application waiting for input. Your browser's window manager reads the event and passes it into the browser process. The browser's UI code sees the Enter event in the address bar, no further typing needed, and invokes its navigation function with the existing URL. That function calls the system's networking API, which enters the OS's TCP/IP stack. First comes DNS. A small UDP packet is built containing a lookup for youtube.com and handed back to the network driver. The driver copies it into the network card's transmit buffer via DMA. The card converts the bits into electrical or optical signals and sends them out. Each router and switch along the path examines the packet's destination IP address, decrements a hop count, updates the Ethernet header, and forwards it closer to your ISP's DNS server. The resolver may need to query root, TLD, and authoritative servers in turn, then returns YouTube's IP address in a UDP reply that follows the same chain home. Armed with that address, the browser builds a TCP SYN segment with sequence number, window size, and options, and sends it to port 443. The YouTube server replies with SYN-ACK, you send ACK, and in a few dozen milliseconds, you have a reliable channel. Immediately, a TLS handshake unfolds. Client hello and server hello messages exchange supported ciphers and random nonces. The server presents its certificate, you verify its authenticity, and both sides derive a shared secret for encryption. With the secure tunnel in place, the browser formats a simple text request, get/, along with headers including host:/youtube.com, and pushes it through the encrypted TCP connection. YouTube's servers process this near instantly and reply with an HTTP OK response, headers, and the HTML content of the homepage. As response packets arrive, the OS reassembles them in order and delivers the byte stream to the browser. The browser's HTML parser reads each tag and text node, building the document object model, DOM. When it encounters a style sheet link, it fetches and passes CSS into a style tree. Scripts without an async flag pause passing to run, potentially altering the DOM. Once HTML and CSS are fully processed, the engine merges them into a render tree, calculates positions and sizes, layout, and then paints the visual elements into drawing commands. Those commands go to the GPU via a graphics API, where triangles are rasterized and pixels written into a frame buffer. Every 16.7 milliseconds on a 60 Hz display, the GPU outputs the latest frame over HDMI or DisplayPort. Millions of subpixels flicker on your screen, and in roughly 150 milliseconds from your key press, the YouTube homepage appears in full color. From the closing of a key switch to the glow of your monitor, electrons rushed through circuits, packets coursed across networks, cryptography secured your connection, and software transformed code into pixels, all governed by physics and precise engineering to bring you the web.